Hello all, welcome back. In this session we are going to see what is simply pruning in decision tree and types of pruning and content related to underfitting and overfitting. So pruning, it is used to reduce the size of a decision tree, and if there is a particular node doesn't provide any additional information, that particular node should be removed, right? So decision tree tends to get overfit when training sample. For example, it becomes the model becomes too large and complex, and a huge complex tree memorizes the training data, but it fails for any particular new test data. So in other words, it is called as overfitting. In other words, while a tiny tree is very simple and it misses the pattern entirely, and our expected accuracy may be 90 percentage, but it may provide only 70 percentage, so it lead to underfitting. So in other words, pruning may be defined as shortening the branches of tree. The process of reducing the size of tree by turning some branches into leaf node and removing the leaf node under the original branch. Now we are going to introduce a term called regularization. Decision tree do not assume the relationship between the input features, that is dependent and independent variables, like linear models. So it is otherwise called as non-parameterized algorithm. Decision tree tries to fit the trained data perfectly, which leads to overfitting always. To avoid overfitting, we need to restrict the decision tree freedom during the tree creation itself. During the development of tree itself, we need to have some pruning. So this method is called regularization or hyperparameter optimization. So in decision tree, the pruning or hyperparameter optimization, in this case I am going to consider for four parameters. One is for maximum depth, minimum sample split, maximum leaf node and maximum feature size. So it depends, hyperparameter optimization depends upon based on the types of algorithm. So what is meant by maximum depth is the maximum length of a path from root node to leaf node. It may vary. So what is meant by minimum sample split? It is a limit to stop further splitting of nodes when the number of samples in the node is lower than this value. For this, consider the value as 5 and the number of samples in the particular node is only 4. So it will stop before splitting. So maximum leaf node, it is to limit maximum number of leaf nodes in a particular tree. For example, 20, it will, if a maximum number of leaf nodes are in a tree, it will limit with that 20. So maximum feature size, it controls the maximum number of features to consider when looking for the best split at a particular node. Fine. And types of decision tree pruning, there are two types. First one is pre-pruning, second one post-pruning. So what is meant by pre-pruning? And we are in pre-pruning, we are not allowing the tree to grow to its full of its depth. In training phase itself, we are restricting the decision tree to stop. In other ways, we call it as pre-pruning is also known as early stopping. It's a pruning strategy in which growth of the decision tree is restricted during the training phase itself. So as an outcome of that, what will happen in pre-pruning? Pre-pruning control tree complexity during training phase. It prevents unnecessary splits early in the learning phase itself. And as an outcome, it produces compact and shallow tree. So it reduces training time and memory usage too. In post pruning, is a pruning strategy in which decision is allowed to grow full of its depth, after which unnecessary branches and leaf nodes are removed. So features of post pruning: it is applied after the tree is fully grown and uses validation or test performance for pruning decision, how the pruning decision performs, that is going to validate it by test performance or validation, and produces well balanced tree with better generalization, typically results in higher predictive stability. So now what will be underfitting? In underfitting, our expected accuracy may be 90 percentage, but your model will perform give only 50 or 60 percentage. For example, in right hand side image, you could able to see here two types of data points, data sets, two classes are there. For this class, the model is very too simple. That's why it gives a straight line. So actually, your model should give only a curved like structure, but it gives a straight line. When the ML model build is to not able to completely learn the trend from the available data, it is called underfitting. So why it usually occurs when the model is very simple and not able to learn the trend properly, and prematurely terminating training to prevent overfitting. In case in the fear of overfitting, we may terminate the training dataset as early as possible. So it results in underfitting due to lack of information features in the input data. So this underfitting can be avoided by following methods: increased redepth, feature engineering, and ensemble methods, and so on. And overfitting, it occurs when ML model builds tries to learn more than its required and results in complex model. So it starts to memorize. See here in right hand side image, there are two classes. It starts to memorize. So over memorizing, what it happens during training, the accuracy is very high. It will be above 90 percentage or 95 percentage. But during testing and validation, the accuracy will drop to 50 or 60 percentage. So overfitting usually occurs in a model while trying to learn all data points in training data and end up memorizing them. So this overfitting can be avoided by following methods. The methods are ensemble techniques, removing unwanted features, increasing data size for training, and mainly hyperparameter optimization or regularization, and stop feeding trained data earlier. Thank you.